Hello everyone. Topic from Group 3 is about the computed tomography with Trainable Fourier series. For the introduction, the CT scan is used for providing widespread use fields such as medical imaging analysis and material science. And the difference between CT scan and MRI is about image analysis. The CT scan and takes no longer than 5 minutes, but MRI is take at least 30 minutes. And is this a picture difference between CT scan and MRI?
Next, we are going to talk about CT image reconstruction. That is how to calculate the slide image given the set of its view. The first method is solving simultaneous linear equation. This method creates one equation for each measurement in the CT scan. That is, a particular sample in a particular profile is the sum of a particular group of pixels in the image. While it offers a good understanding of the problem, solving several equations is expensive and impractical. The second method is use iterative technique to calculate the final image in small steps. There are several variations like ART, SIRT, and IRST, and the difference of this method is how they update the image during each iteration. As an example of this technique, we will look further at ART in the next slide.
ART algorithms, all the pixels in the image array are set to some arbitrary value. An iterative procedure is then used to gradually change the image array to correspond to the profiles. Iterative techniques are generally slow, but they are useful when better algorithms are not available. In fact, ART was used in the first commercial medical CT scanner released in 1972. Filter back projection. In more formal terms, the point spread function of back projection is circularly symmetric and decreases as the reciprocal of its radius.
Filter back projection. In fact, the image produced by filter back projection is identical to the correct image when there are an infinite number of views and infinite number of points per view. Fourier reconstruction of a CT image requires three steps. First, the one-dimensional SFT is taken of each view. Second, these view spectrum are used to calculate the two-dimensional frequency spectrum of the image. Third, the inverse FFT is taken of image spectrum to obtain the reconstruction image.
For the feature is about the graph of frequency response and filter kernel. It is the radial arrangement and is the back project image. And the rectangular grid is about the correct image. If you compare that, we find that the sample values are identical. And the filter in filtered back projection is an unequal sample density. In the particular, the frequency response of this filter must be inverse of sample density, and the filter kernel is then found by taking inverse of Fourier transform as shown in the equation.
First one, h0 equal to 1, 2, hk equal to 0 for even values of k. And the last equation, hk equal to minus 4 over by pi to the power 2 and over k to the power 2 for the odd values of k. This is the equation that we used in the previous graph that we discussed. Thank you for your attention. I hope that you have a good information for you. If you have any question, you can ask.